Welcome to Lecture 2. We are going to be looking at food webs and how energy flows through food webs. The last class, we talked about food webs and what food webs were. We built a food web with all of our critters. Food webs, as we now know, really trace the flow of energy through an ecosystem. So you are getting your energy from whatever you eat, and so therefore within a food web, you can look at how each organism gets the energy it needs to survive. The sun is providing the source energy for almost every food web on Earth, but not all of them. There are some food webs, such as deep on the bottoms of the oceans. There are some food webs down there which don't rely on the sun at all. However, we are going to focus on sun-based food webs. If ever you're interested in some of the deep sea food webs that are really cool, they rely on chemical energy. There's some great videos of them through Blue Planet where you can actually explore some of the deep ocean food webs. But back to our main topic, food webs and energy. What is energy? It's somewhat hard to define, and so therefore we're going to give a primer on energy and the laws of thermodynamics. Energy, as defined in physics classes, is the ability to do work, but that really doesn't mean much to me. If somebody said energy is the ability to work, yeah, I know when you work, you use up energy, but it's hard to understand energy as a concept with that definition. So therefore, what we're going to do is think about some examples of energy. You can divide up energy into two different categories: kinetic energy, which is the energy of motion and moving things, and potential energy, which is stored energy that can be used for other things. Thinking about kinetic energy first, the most kind of intuitive form of kinetic energy is objects that are moving. The kinetic energy of motion. So a ball bouncing, a person jogging, a car going down the street. Anything that's moving has kinetic energy of motion. Another form of kinetic energy is heat. And talking about heat and thinking about heat, we're thinking about molecules that are moving. So the very smallest little bits of atoms and molecules that make up all of the things on this universe, when those molecules move, you have heat. And so therefore heat is considered kinetic energy. So therefore fire, an oven, anything that is warm or heat, all of that is a form of kinetic energy. Another form of kinetic energy is light. And light, you can think of that as photons moving. You might have heard that light is made out of these little particles called photons. And so anything that is moving at the speed of light, those are little photons moving at the speed of light, is going to produce what we see as light. So light bulbs and glow sticks and so forth. Finally, another form of kinetic energy is sound, because sound is based on air moving and causing our eardrums to vibrate. So music and voices and what you're hearing right now when I'm speaking, that is a form of kinetic energy. Now the other category of energy, potential energy, is stored energy. What I mean by stored energy is that I have some energy stored in something, and then I can release it and turn it into motion or heat or light or sound. So for example, gravity is a form of potential energy. If I lift a ball up a little ramp and I just give it a little push, it's going to fall off the ramp or fall off the cliff, and it's going to turn from a gravity potential energy, stored the energy in the ball by lifting it up high, then suddenly it releases its energy and now it's in motion. It is now gone from a gravity potential energy to a motion kinetic energy. Other ways you can store energy to release later is with elastic energy. Elastic potential energy. So if you stretch a rubber band, or you compress a spring, or you store energy in something that's stretched or compressed, the elastic waistband on your clothing would be a form of elastic energy. If you crush something and then when you release it, it expands, then you're talking about elastic energy. Like if you take an inflated ball and push it down, when you let go, it's going to bounce up again. So that's a form of elastic energy. Another form of potential energy is chemical energy. And chemical energy is anything that's going to start a chemical reaction. In our purposes in this biology class, this chemical energy is a very important thing because sugar and fuel that you can burn is a form of chemical potential energy. For instance, when we eat sugar, we can think of it as that we're eating that sugar so that we can burn it later and release it in the motion of our bodies. So sugar, when we burn it in our bodies, that's fuel and energy for our bodies. That chemical energy, which is the sugar, gets turned into the movement of us walking and running and moving around. Finally, we can think of another form, our last form of potential energy is electrical energy. And electrical energy is simply a difference in charge, but we think of it mostly as, for instance, a battery or static electricity. Electrical energy are things that, if it's released in the right way, will turn into light and sound. For instance, you can, off of a battery, run a light bulb, or you can run your iPod, all of which are creating light and sound out of an electrical stored energy. Now that we have a kind of context in which to think about energy, hopefully you can see how energy, all of these types of things, are ways that you can do work. You can do work by moving around. You can do work by storing up some energy in gravity and then releasing it. All of these things will allow you to do work, will allow you to do something. So, now that we've talked about these, I'm going to quiz you. This is a kind of little game thing. I want you to name the form of energy in a picture that I show. So right now I've listed off all the different types of energy. I've given you a little summary of them. And so as I show you a little cartoon, I want you to be able to identify the form of energy in my cartoon. First one, late at night, without permission, Reuben would often enter the nursery and conduct experiments in static electricity. What form of energy? If you said electrical potential energy, you are right. Congratulations. So, I hope you understand the point of my game now, and I'm going to show you another cartoon. This is Tethercat. What form of energy? If you said that it's the kinetic energy of motion, you are right. Congratulations. Let's take a look at another one. Identify the form of energy here. If you said the kinetic energy of sound, you are right. The guy is about to burst a big inflated paper bag behind that other scientist. What about this one? This one actually has two different forms of energy shown. There's the kinetic energy of heat and the kinetic energy of light. But heat might be the primary one. Let's look at another one. Laboratory peer pressure. If you said chemical potential energy, way to go, good job. How about another one? On October 23rd, 1927, 3 days after its invention, the first rubber band is tested. It's elastic potential energy. How about this one? Eraser fight. That would be the kinetic energy of motion. Good job.